All right, welcome to track one. Hopefully some of y'all are Windows domain admins because this talk should be interesting to you. You should pay attention. With that, here they are.
Thanks, Flickted. So I want to make sure I got the right mic. Can the people in the back hear me okay? Awesome, thank you. So we are talking about 6 degrees of domain admin. If you're not familiar with this phrase, there's a very common game in the like film geek world called 6 Degrees of Kevin Bacon, where you can take any actor, any director, any movie, and just by making 6 connections, you can find a way to go to Kevin Bacon. I don't know why it's Kevin Bacon, that's what it is. So we have found a way to do that in an Active Directory environment, and domain admin is the most obvious target, so that's what we selected. Is there a little bit of feedback? Maybe we should back off a little bit. Okay. About us. My name is Andy Robbins. I've been a professional penetration tester and red teamer for 4 years. I originally cut my teeth in the financial services industry. I'd really love to talk to you about ACH files if you're interested in talking about that. All 3 of us work at Veris Group's Adaptive Threat Division. With that, I will pass it over to Rohan.
Hi, I'm Rohan Vazarkar. I'm another penetration tester at Veris Group. I've been doing penetration testing for about 2.5 years. I work on a lot of open source projects, and I was responsible for the web UI for this one.
Hi, my name is Schroeder. My handle is Harmjoy. I'm a researcher at the Adaptive Threat Division, and I've built a good number of our offensive kind of tool sets that we've used over the last couple of years, most notably PowerShell Empire and also PowerView, which kind of acts as the data collection component for Bloodhound.
Any PowerView users in the room? Lots of you, awesome. Yeah, give Will a hand. Give Will a hand for PowerView. Yeah.
And also, this is their first time here at DEF CON, so give them a hand too real quick. It's their first time speaking.
All right. Let's talk a little bit about the current state of Active Directory domain privilege escalation. First of all, I want to talk about this quote a little bit. This is stated by John Lambert. He's a general manager at Microsoft's Threat Intelligence Center. John said, "Defenders think in lists, attackers think in graphs. As long as this is true, attackers will win." There's a great blog post where John goes into some depth about what this concept means effectively. What I hope that we can show you is that not only are we going to start thinking in graphs, we're going to start using them practically to automate a lot of our work. So first of all, with Active Directory domain privilege escalation, Active Directory is effectively ubiquitous. In Sean Metcalf's talk, he stated that of the Fortune 500 in the United States, more than 90 or more than 95% of organizations use Active Directory. To the people in this room, that's probably a given. But what does that ubiquity actually mean in the real world? That ubiquity means that Active Directory is a subject of a lot of attention, not only from defenders, but also from attackers. So that means that there is a lot of time, energy, money, blood, sweat, tears, going into learning how to best defend Active Directory environments and also how to attack them. As penetration testers and red teamers, we have the benefit of every so often getting these nice easy buttons that make us look like elite hacksaws because we use the right module to basically do like a point-click escalate rights. MS-08067, MS-1468, Kitrapod, GPP, the list goes on. What's the problem with these easy buttons? The problem is that they are ephemeral. They have a tendency to go away. Especially over the past 4 or 5 years, enterprises, at least in the United States, have started paying attention to a lot of the things that people in this room have been saying for a long time. Do patch management, run vulnerability scanners, audit the results of those vulnerability scanners. So those vulnerability management practices are getting more mature. That means that when you land into an environment and they have that kind of maturity, those easy buttons may not necessarily be available to you. So let's look at this in a visual way. We have an example of a very simple Active Directory environment where we have 16 computers. Now let's say this red computer is kind of our initial access. Maybe it's Cobalt Strike Beacon. Maybe it's Meterpreter. Maybe we're a malicious insider and we just have access to Active Directory. Bottom line, we have authenticated access to AD. Now, thanks to Will's work with PowerView, it's very easy to identify systems that a domain admin is logged onto. In fact, you can typically find out where everybody in the environment is logged onto, which will be very important later. So let's say we identify this is the box where the domain admin is logged on. Now, this client organization that you're in, they don't have the best patch management. They don't have the best vulnerability management. So you escalate rights on this one initial machine. You dump the NTLM hash for the RID 500 system. They've applied KB 287-1997, but they haven't disabled the local admin account. What does that mean for you? That means that all these computers all of a sudden light up, and now you have kind of notional administrator access to them, including the box that the domain admin is logged onto. So you use your favorite pivot method, maybe psexec or WMI. You pivot over to the box the domain admin is logged onto. You run memcats. You get the password. Now you have access to the entire environment. Awesome. Who's executed an attack path exactly like that? Like a billion times. Most everybody. Let's take a look at a slightly different example. So in this environment, the client actually does have proper patch management and vulnerability management programs. So you're not going to be able to find MS-08-67. You're not going to find MS-1468. You're not going to find GPP creds. However, in our experience, 99 times out of 100, we are able to gain some kind of initial privilege access into an environment. Most typically, this actually happens with clear text credentials that are in a file share that anybody who's authenticated to AD can view and read. Logon scripts are probably the most obvious example. So let's say that we find one of those credentials, and okay, so first of all, we found the DA. He was logged on. He's in the same box. We use those credentials, and we identify systems that we now kind of have notional or provisional administrator access to. We find these 3 boxes, and we find out who the 3 people are who are logged onto those systems. Unfortunately for us, none of those people are a domain admin. Additionally, none of those users have administrator rights to the box that the domain admin is logged onto. So we have this kind of missing link that we have to identify. Typically what we do is we go into this kind of credential dance, or what Microsoft referred to in 2009 as an identity snowball attack. So what does that mean? That means that we have to choose one of these systems to pivot to. You can use manual analysis to try to figure out what system that is, but eventually you're just going to have to guess. So let's say that we pivot to this machine up here in the top left. We get this guy's credential. We do the same thing. We figure out what systems does this guy have admin rights to. Okay, now we have some new boxes. However, again, not a DA. And again, none of those users have admin rights in the system the DA is logged onto. So again, we have to guess. So let's take our best guess, and we say that maybe this guy is part of a help desk group. That sounds like a pretty good group. That probably has some high privilege. So we pivot to this box, run memcats, get his credential, and then we find out this guy doesn't have any more rights in the environment than what we already have. Hate that. So we have to go back. We have to go back to the system in the top left. We have to make another guess. Let's say we go to this system. We run memcats again. We get this guy's cred. And then lo and behold, who should appear but the domain admin in the systems that we have this kind of notional administrator privilege to, now that we've gone 2 hops away from where we originally started. We pivot to the DA. We run memcats. Now we have admin rights in the entire environment. Who's in an attack path like this, or who's read a report where credential abuse is used in that kind of attack path? A lot of you. Cool. We refer to this attack, or this methodology, as derivative local administrator. Justin Warner, who on Twitter you can find at 6dub, he defines this as the chaining or linking of administrator rights through compromising other privileged accounts. At MSRC in 2009, Alice Zhang and John Dunnigan put a great white paper out about a method or a capability that they had called heat ray that goes into very extreme detail about how they kind of understood this process as well. Highly recommend that you go read that white paper. So let's look at this a little bit simpler. Let's say we have this user, Bob. Bob has admin rights to PC1. On PC1 is this user named Mary who is logged on. Mary has administrator rights to PC2. Bob derives administrator privileges to PC2 via stealing Mary's credential. Make sense? Cool. How else can this happen? This can also happen with Active Directory group delegation. When you add a user to a group, that user gets all the privileges of that group. When you add a group to a group, that nested group gets all the privileges of that group. Let's say Bob is a member of this group called Help Desk. Help Desk is a member of a group called Server Admins. Server Admins has admin rights to PC2. See a lot of nodding heads, like this is pretty good. This is pretty basic stuff. This is what the entire methodology or the entire core of Bloodhound is based on, is this concept of derivative local admin. So derivative local admin is extremely... Sorry about that. Derivative local admin is an extremely effective attack, but it has some very serious setbacks and challenges that we need to be aware of. First of all, it's extremely time-consuming and it's extremely tedious work. If you've gone through the process of manually going through this method, you understand this very well. You have a complexity override, essentially, of where each step you go, the analysis steps that you have to do grow exponentially. Next, it's not comprehensive. So imagine the difference between taking a report to your client or as a client getting a report from a pen test firm. Imagine the difference between reading, this is one attack path that we identified in your environment, versus here are all of the attack paths in your environment, okay? Next, you have limited situational awareness. You may not even understand, you may not have the ability to understand what kind of privilege you currently have in whatever user context you're running in. Finally, the last thing I will say is, did you even need DA? If your target is like an HR system, it's going to be simple to escalate to DA and then go back down to the system that you actually need. But you may not have even had to go through this rigmarole of escalating DA in the first place. All right, we're going to talk about graph theory. I'm going to take a drink of water real quick. Graph theory has been the missing link in this process that has been keeping us from automating the entire process. I'd highly recommend you look at the history of graph theory with Leonard Euler using it to disprove or to prove that there was no solution to the 7 bridges of Königsberg problem. Super interesting stuff. We're also going to look at the design of our attack graph. So the basic elements of a graph. First of all, a graph is not necessarily just a visual thing. A graph is a construct of a discrete branch of mathematics called graph theory. So in a graph, you have vertices or nodes. Vertices are used to represent a basic individual element of the system that you're representing. If this is Google Maps, then a vertex may represent a city or an intersection. Edges are used to represent relationships between these vertices. If Seattle, Washington is a vertex and Portland, Oregon is a vertex, then Interstate 5 could be thought of as an edge that connects those two cities. Finally, paths, the most crucial part of graphs. Paths are used to connect otherwise disparate nodes, regardless of how far away they are from each other. This is where the key difference between a graph and a relational database comes into play, which we'll talk about later. Here's a visual way to look at the same thing. So here's a very simple graph. We have 2 vertices, and we have an edge. This is a directed edge, or it's one way. You can think of it as a one-way street. You can go to vertex, you can go from vertex 1 to vertex 2, but you can't go the other way. Paths. Can you see a path from vertex 1 to vertex 4? Yeah. Is there a path from vertex 3 to vertex 4? No, because you would have to go the wrong way against a directed edge. So after a lot of false starts, we finally landed on an attack graph design that works. And here's how it looks. The vertices are used to represent users, groups, computers, and domains in Active Directory. The edges identify the relationships between those. So this means admin rights, group membership, user sessions, and domain trusts. Finally, paths always lead towards escalating rights, period, always. This makes writing our pathfinding queries very, very simple. Again, let's look at this visually. Like I said, users, we have 2 users in this graph, Bob and Mary. Groups, we have 2 groups in this graph, IT admins and domain admins. Computers, we have 1 computer, server 1. First, let's identify group memberships. We find out that Bob is a member of this group called IT admins, and we find out that Mary is a member of this group called domain admins. Next, we figure out privilege. Who has admin rights where? This group called IT admins has administrator rights on this computer called server 1. Finally, let's find out where people are logged on. We find out that Mary is logged on to computer 1, or put another way, computer 1 has a session for this user. Is there a path from Bob to domain admins? Yeah. Bob is a member of IT admins. IT admins has rights to computer server 1. Server 1 has Mary logged on. She's a domain admin. We've got our path. This is the core fundamental concept for Bloodhound. Let's put this very simply. In order to use a graph, you need to populate it with data. What data do we need? Who's logged on where? Who has admin rights where? What users and groups are part of what groups? That's it. That's all we need. Will is going to take over now, and he's going to talk about how we actually do this data collection.
Cool. All right, so I'm going to go over some stealthy data collection with PowerView. I'll let you guys read this quote. This was extremely kind of weird for me. We obviously do not advocate the malicious usage of our tool sets, but you know, what can you do? So we have our little puppet Phineas Fisher up there. So PowerView, we saw some PowerView users in the audience. PowerView is a PowerShell 2.0 compatible domain and network situational awareness tool. I started writing this a couple of years ago to automate a lot of the offensive and some defensive tradecraft that we execute on engagements. It's completely self-contained. It's a single PS1 PowerShell script. It can be loaded into memory. There's no external dependencies. Nothing has to be added to the machine. PowerView collects the data the Bloodhound is built on. And what's really cool is that in most cases, you do not need any kind of elevated domain access to gather this information. And I'll go over the different components here in a second. So just as a domain authenticated user, you do need a session like that, but no privileges at all, just in domain users, the parent group. You can collect a huge amount of information from Active Directory through a couple of different ways. So, Andy mentioned the 3 components of information we needed. The first is who's logged on where. We refer to this as user hunting. So the main function in PowerView that does this is invoke user hunter. It was one of the first ones written. It's an extremely common one that people tend to run. It utilizes a couple of Win32 API calls under the hood, the most useful being net session enum, to where you can point these functions to remote systems and figure out who has sessions established with that remote box. Again, not having to have administrative rights on that remote system. So you can run this against a domain controller or file server and get a really nice mapping about who's logged in where. There's also a stealth option. By default, Invoke User Hunter will enumerate all machines in the domain and run these enumeration actions against every single machine. This can be extremely noisy in some contexts if anyone's doing internal network-based monitoring, but it gives us a more complete data set. With Stealth, we use a couple tricks to where we enumerate all user objects and we try to pull out properties that may indicate highly trafficked file servers, something like profile path, and collect all those things in and run a net session enum against each system. So it's much faster, but we don't get quite as accurate data. Next, who can admin what? This is the craziest thing to me. I love this. So as an unprivileged user, we can enumerate the members of a local group on a remote machine without needing administrator privileges on that remote machine. There was a couple of tools out there that did this. I weaponized it up in PowerView, and we use this function specifically on almost every single engagement. There's 2 ways you can do this. You can use the WinNT service provider, which is a remnant of NT domain deployments, and you can also use this particular net local group members call. Just point it to a remote server, and it happily gives you back who the members of local administrators are, their domain SID, whether they're a group or user. The function in PowerView that does this is get net local group. You just pass an IP, a NetBIOS name, or a computer name. If you would like to use the API call, you can do the -API flag. By default, it does the Win32 provider. We also have a kind of different new kind of method to do this, to gather the same information. So I worked last year with Sean Metcalf about how to kind of structure this approach. Group policy objects are just collections of settings that are applied to computers. Some of these settings are who are in the local administrators group for a particular machine. This is either through restricted groups or group policy preferences. GPOs are linked to OUs and sites. So if we enumerate all the GPOs and we enumerate all the other domain containers and do a little bit of correlation magic in the back end, we can get a mapping of who can administer what machines through GPO object modification. Now, this is not going to be as accurate because you're not touching every machine, and you're not, so if somebody specifically adds a local user to a machine, it won't show up in this method. But what's really cool in this approach is that you're only communicating with the domain controller through LDAP. You're not sending a single packet to any other machine. The Power View function for this is find GPO location. By default, it'll just give you a nice raw mapping of everyone who can administer what machines through group policy object correlation. The last part, who's in what groups? This is the easiest. We just enumerate all the groups through LDAP and pull out all the members of each. Power View is just getNet group, pipe to getNet group member. This is the PowerShell pipeline. What's really neat about this is it'll pass fully serialized objects between all the different functions you're running. So it's super, super easy. We do some kind of variation of this in almost every engagement as well. And that's it. So let's bring it all together. There's a customized version of Power View that is integrated with Bloodhound. It has all the stock Power View commandlets along with a couple of extra features. Get TAC Bloodhound data will automate the gathering of Power View data on a domain. By default, it'll only gather the data on the current domain, but it'll get the trust, group memberships, and all these things that we talked about. There's a lot of different targeting options. If you want to use stealth, there's -stealth and things like that. You then take that function and you pipe it to one of two export functions. Export Bloodhound data will export all those custom objects, package them up with Cypher queries for Neo4j, which is what it uses on the back end, and then shuttle everything off to the Neo4j batch RESTful API ingestion interface. So if the collection machine can reach the analysis machine, whether on the same domain or through something like a reverse port forward, which we have done in the field and it does work, then you can just shoot this stuff straight into Neo4j and then Bloodhound without touching disk. If you can't reach the analysis server for some reason, you can pipe that get TAC Bloodhound data to export Bloodhound CSV, which will take all those same custom objects and export them into 3 or 4 different kind of custom CSV files. We have a particular format which we've documented. The CSV files can then be ingested offline into the Bloodhound analysis interface. Are we on time? Good. Let's start the demo. Yeah. Okay, now Rohan's going to go through a live demo of Bloodhound.
All right, so, I'm not trying to hide it from you, I promise. I'm going to mirror the screen. All right, perfect. So when you first fire up the Bloodhound UI, you're presented with one of our favorite views, which is what are the domain admins inside the environment you're in, and who are the members of these groups? Generally speaking, when we're in assessment, we tend to target domain admins a lot, as we talked about earlier. They pretty much have keys to the kingdom, and usually whatever target we're going after, one of them is going to be able to get to it. Any node that is in the environment can be auto-completed using the search bar up here, so it'll help you find stuff you need. We're going to actually start with a user. Any user you click on is going to present you with a bunch of information about that user here. So the first thing we can see is first-degree group membership. These are all the groups that our user is part of by default. The next thing you can see is unrolled group membership. Now, a lot of times this is actually kind of a pain to enumerate properly, especially when groups get really, really nested like the one you see here. The next thing we can look at is group delegated admin rights. If this user was added to the local admins of any machine explicitly, that would be here. But because we're not, we're just going to look here. This is every single system that this user has access to based on their group membership. Now, to keep the graph a little bit more readable, we do a lot of collapsing of nodes. So if you can see there's an 87 next to domain admins node here. Slow down. All right. There are 87 other computers. I can't slow down, sorry. There are 87 computers that are folded into the domain admins group. Now, if we displayed all of these, the graph, as it gets bigger and bigger, takes longer and longer to lay out. So this is more of a performance thing. Any node that is collapsed in, you can actually expand by right-clicking on it and hitting expand, which I'm not going to do because it'll totally break the graph. So in this one more thing you can look at is derivative local admin rights, which is what we were talking about earlier. Now, this graph here is showing from our user any path that this user can take to get to any other computer in the environment, whether it's through group membership, through local admin rights, or sessions of users that are logged into computers which you have admin rights to. Now, navigating this graph can be a little difficult, and there's a lot of nodes here, so we introduced a feature called Spotlight. Using Spotlight, you can search the graph you're currently on for any nodes. So we're going to look for this research group here. Whenever you click on the Spotlight, it'll zoom in on the node so you know where it is on the graph, and it'll pull up all the information on the left so you can start interacting with it. Move it around. Here we go. So there you go. It's the node. Ooh. You can ask Bloodhound to give you who the direct members of any group are. You can see there's 4 more that are folded here. We can expand this, and you'll see that these are users. The next thing you can ask Bloodhound to give you is the unrolled group members of a group. As groups start getting nested, it becomes more and more difficult to find who the real members are. So Bloodhound makes it really easy to do that. You can also ask Bloodhound what direct administration rights a group has. So we expand this, you can see there's 28 different computers that this group has direct admin to. Just like with a user, you can calculate derivative local admin rights. It'll use wherever you start, and it will try any path it can find to any other node in the domain. Another really handy feature we have is sessions. Using this, you can ask Bloodhound to tell you where every single user that is a part of either the group or subgroups is logged in. A lot of times when you're on an assessment, you know that there's a specific group that users belong to, and that group is where you're targeting your crown jewels. Let's say it's an HR group and you're trying to access their information. With Bloodhound, you can ask where are all the HR members logged in, and it'll give you every single computer that it has a session for. Now, on this group, we're going to find ourselves a computer, SQL 2. We'll pretend like this is something cool here. You can ask Bloodhound who the explicit admins for a computer are. These are first-degree admins. So if you run net local group administrator on a system, this is the output you'd get. You can also unroll the admins on a computer. In this particular case, there are 6 groups that have local admin on this system. However, once you unroll it, it becomes 51 users with administrative rights. As Active Directory domains expand and they keep getting more and more things inside of them, groups can get nested. You can easily lose track of who's admin on a system because of nested groups just continuing to obscure what you're looking for.
One thing I would add to that is this example is showing an order of magnitude difference between who is explicitly defined as an admin on this system versus who gains admin rights through these nested groups. And that kind of difference in an order of magnitude we see is very, very common on almost every assessment that we go into.
You can ask Bloodhound to give you the sessions for a computer, who's logged onto there. It's extra information that's always handy. And just like with a group or a user, you can ask Bloodhound to calculate the derivative local admin rights, provided you started from that computer. Now, getting into one of the most powerful features of Bloodhound, we're going to talk about pathfinding. Bloodhound provides you the ability to find a path between any one node and any other node, provided that path exists in your database. So just to give you guys an example to start, we're going to pick a user, Jay Druin, and we're going to ask Bloodhound to take us to the domain admins group. Now, walking through this path, Jay Druin is a member of a group, Information Technology. Information Technology has local admin rights to all these systems here. Each one of those systems has a user session for a domain admin. So if you jump to these systems and Mimikatz, you would have the password for a domain admin. Now that's a cool example, but let's amp it up a little bit. We're going to take this user Jay Nickel at external.local, and we're actually going to ask Bloodhound to take us to domain admins at internal.local. Now, internal.local and external.local are 2 different domains in the same forest. So if you follow this path, our user is a member of a group, which is a member of another group, which gets us admin rights to several systems. We can steal a session from one of those systems and get a different group membership. That takes us to another system with a user in external.local. However, the next hop is in the internal.local domain. Despite the fact that we're jumping a trust boundary between two domains, Bloodhound just is using the data available to it, and it has no problem enumerating these paths. No matter how complicated the path is, if the path exists, Bloodhound will be able to enumerate that path properly.
So one thing that I would add to that, a common question that we've been getting over the past week when we're publicly demoing Bloodhound for the first time is with regard to scalability. So we went into an environment that had 200,000 computers, Windows workstations and servers. They had about 90,000 users. They had about 75,000 groups. Tracking all that information manually is just not possible. So they also had more than 75 domains, I would say, in a forest with varying degrees of trust. With the stealth option that Will talked about with ingestion, it took us about 20 to 30 minutes to collect all the information we needed from this global enterprise to identify attack paths. Doing the query with Neo4j in a graph database is just as fast as what you're seeing here. In that environment I'm talking about, with 200,000 computers, more than 75 domains, Bloodhound found us an attack path to go from this tiny little domain that was relatively insecure to this very high security domain where our actual objective was, cross 6 domain trust boundaries, taking advantage of users that had relatively low privilege, like 4 machines that they were admins on. But it just so happened that one of those machines had a user that gave us more privilege in the environment until we got to what we needed. Thanks. Thank you. One additional thing that I would say is I mentioned the stealth option took about 30 minutes. If you're going to do non-stealth and you're actually touching each system one time, that ingestion takes between 24 and 36 hours. For that level of environment, 200,000 systems.
All right, so just demonstrating some more stuff that we've built in to make this even easier to use for everybody. We have several pre-built queries that you can access through the UI. There are some really good ones here, like finding the user with the most sessions. Let's go ahead and identify which user is logging in way too much. In this particular case, it's antivirus, which is sort of okay, but if I get that account, I'm going to be pretty happy. You can also find the computer with the most sessions. This is demonstrating things that tend to be used a lot, such as IT jump boxes or terminal servers. These are high-value targets that if you compromise them, you're very likely going to get a large set of credentials. You can also hit Control here to show all the node labels, or you can hide them all, or you can just show the default. These are just display options to help you whenever you're showing these to other people. Another thing that was added very recently, and when I say recently, I mean last night, was the ability to query any user in a domain of your choice and find what foreign group relationships they have in other domains. Historically, this has been a very tedious and time-consuming task. So in this particular case, querying the internal.local domain, we're given 3 users that are members of groups in the external.local domain. Another query we can do, and this is one of our favorites, is find shortest paths to domain admins. When you click on this, you get a selection. Which domain admin group do you want to use? So let's say we wanted to use internal.local. What you're seeing here on this graph is every single possible path that Bloodhound can find to go from any node in that domain up to the domain admins group. Now, when we were talking about earlier showing all the paths to your client, this is what we're talking about here. It's really great because you can look at high-value targets that if you remediated would actually cut off a lot of points. For example, this node here, you can see has several connections out to it. If you were to go and lock down that computer, you'd significantly reduce the attack surface of that domain. Now, any graph that you generate in Bloodhound can be exported either to JSON or an image. You can export it to JSON and load that into other graph tools, or you can re-import it back into Bloodhound if you have some particular graphs that you like saved. You can export it to an image and throw that directly in your out brief. It's great value to show your clients. It looks really cool, and everybody likes pretty pictures, so. As Will was talking about earlier, you can export all the Bloodhound data instead of directly to the database through the CSV ingestion here. When you click this, you can just give it a file, and it'll ingest everything exactly the same way as if it was from the PowerShell script itself. This is great for a lot of situations where, for whatever reason, your host that you're running your ingestion from can't talk back to your database. Let's say there's really good firewall rules. You can just download the CSVs directly from the host and throw them into the web interface, and you're good to go, just like before. I think that's the whole demo.
Thank you. So we have 10 minutes left. One thing that I would like to briefly touch on that we skipped is kind of the architecture of Bloodhound, because there are some very important other open source projects that Bloodhound relies on. First of all, Linkurious.js is the open source and free version of Linkurious. If you are developing a web front end like this that interfaces with Neo4j, Linkurious is where you want to go. It's built on top of Sigma, so you have all these things kind of abstracted away from you that are otherwise very difficult if you're not a JavaScript expert. Secondly, it's compiled with Electron, so it is cross-platform. And then most importantly, we rely on Neo4j as our graph database. And then obviously it's fed by the PowerShell ingester. So, this is the part that Rohan's been waiting for.
Yeah. All right, let's do this. So we have here the Bloodhound repository, which to this moment has been private, and we're just going to go ahead and YOLO this right now. Uh-oh, this is bad. I'm going to have to log into GitHub. I just ruined everything. Andy, why didn't you make me check this? It's okay. This is why I use two-factor, right?
Yeah, so while Rohan is doing this, the license that we are releasing this under is GPL v3.
No, I'm good. I'm not afraid of these people.
Once we get done with this... Okay, here we go.
All right, and there we go. It's public, I promise.
So we have a nice, easy link. Get your phone out, take a picture, bit.ly/getbloodhound. You can find me on Twitter. Again, my name is Andy Robbins. My handle on Twitter is @_Waldo with a 0. Rohan. Oh, go back. Sorry. There you go. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Get it from your neighbor. Socialize. Professional network. Meet somebody, please. My name is Andy Robbins. You can find me @_Waldo with a 0. Rohan Vazarkar, you can find him on Twitter @CaptainJesus. Will Schroeder, you're already following him on Twitter @HarmJoy with a 0. Thank you very much.
By the way, we decided to be really nice to you, and we have pre-compiled binaries for every OS and architecture. So
I think we have 5 minutes for questions, and this gentleman is first.
Big one,
Can you speak into the mic? I don't know if it's on. There you go. You're good.
Oh, there we go. Big one is you have Git sessions. So it's
Get right in there. Yeah.
big one is you have Git sessions. So live data. They have to be logged in to see the path.
Okay. So his question was with user session information. You got a second question as well.
Tied into that. So you have current sessions to do your jump.
Do we have what?
You have your current session to do your jump, logged in users. What about pass the hash of a local admin hash to jump? Does Bloodhound take that, or local hash match to domain, where you can take a matching hash and jump?
Okay, so his question is with user session information. When we're collecting user session data, the user needs to have a valid session that is currently with a domain controller or a file share. So you may find yourself recollecting user session information frequently. because of the nature of how that works. Your second question was with local accounts, with RID 500, with Pass the Hash. Right now, we are only tracking domain accounts. We are not tracking local accounts at all. But we may put that in the future.
Is it jump from local up to domain with matching hash?
Oh, okay, so also the question of like reuse passwords from like a local admin that has the same password or NTLM hash as a DA, we're also not tracking that as well. You should check out a project called AutoDane from SensePost. That may have what you're looking for. Yeah, thank you. Thank you for the question.
Hi, do you count for stuff like laps being rolled out into the environment?
So the question was, do we account for laps being being distributed through the environment? That we also do not account for. So any kind of like credential sharing against systems or, as a matter of fact, a better answer to your question is this was born out of a necessity to bypass laps protections. Because we couldn't pass the hash of a local admin account, we had to rely on domain user level accounts.
And I will also say that we have a couple things going forward we want to integrate. One of those will be Active Directory ACL enumeration and auditing.
Yeah.
So it'll automatically, in a few months when we finish extending the schema, we will ingest all Active Directory ACLs into the graph and everything will be integrated. So you might be able to tell who has read access to the password attribute for laps and then integrate that into the attack graph.
Yep.
Awesome, thank you.
Thanks for the question. Hey.
Thanks, guys. How are you handling how this stuff changes over time?
Okay.
Right? So the date.
Yeah, so the question is, how do we handle this data as it changes over time? Excellent question. So we treat local admin privileges and group memberships as relatively static information, that it doesn't change that much day to day. User session information we treat as relatively dynamic. So in our wiki, we provide guidance on how you can re-ingest gist session information. Additionally, we're planning on adding temporal information to the user session edges. So what that means is that if you're an incident handler and you want to go back and you say, we had an initial breach on March 16th, I can tell Bloodhound, go back to March 16th, tell me from this computer to every other system in the environment based on the currently logged on users that I could get info for, show me like from patient 0 what was possible, and so that I can more clearly define my investigative scope. That brings me to another point, is that from the offensive side, this is really cool, and we like it a lot. What's really cool is the defensive applications. And so over the next 6 months to the next year, we're going to be focusing primarily, almost exclusively, on defensive applications like that. Thanks.
So more and more often, the people that I'm popping end up using Macs. So while obviously their computers aren't joined at the domain, many times they have valid LDAP credentials. Is there a way I can use those valid LDAP credentials with Bloodhound somehow?
Yes. So in our wiki, we have a section about data ingestion with other tools. So right now, we're talking with Bytebleeder, the author of CrackMap Exec, to get support for other tools like that. So if you're in OS X, if you're in Linux, you want to collect information, you don't want to be running in PowerShell or running on Windows, we're planning on getting that in there as well. We have developer notes about the CSV format and how to actually get info into the Neo4j graph database. We're going to have to move in here. And we're going to have to leave in a sec.
Awesome.
Thanks for the question. Guys. How much time do we have? One more question.
Great. What are the top 3 things you can use for defense to help that you would tell everybody to do?
So your question was, what are the top 3 things Bloodhound can do for defense? Mm-hmm. So I would say that number 1 would be mitigating the attack paths that rely on derivative local admin. So in the Microsoft white paper, the product that they're describing, the MSRC developed, is called HeatRay. They use graph theory, and they also use machine learning to give an IT admin a list of, like, here are the 10 changes that you can make in the environment that will most efficiently eliminate the largest number of attack paths based on credential abuse. Secondly, I would say that one of the major benefits is a more clear and easy understanding of nested group memberships and how those relate to local administrator privileges. And then number 3, let's talk offline.
Yeah, let's go.
We have to go. Thank you again.
Thank you.
Thanks.